Hello everyone, Nicole Steckline, Technical Agronomist for DeKalb and Asgrow in Northeast Iowa. There were probably a fair amount of soil tests that got taken during the fall, so we're starting to get those results back and determine our fertility plan for this coming spring. As much fun as it is to run to the phosphorus and the potassium to see where our fertility levels are, we kind of got to do something first, and that's looking at our pH and determining if we need any ag lime. So pH is really important because it's going to influence the availability of the nutrients in the soil, and it also greatly influences the activity of the microbes. And the microbes are what keeps these nutrients, cycling to begin with. So we need to correct our pHs. Now, in Northeast Iowa, our typical issue is that we have too low or too acidic of a pH. When you look at places like the Des Moines lobe, typically their issue is going to be that they are too high on that pH scale. There's not a whole lot we can do to, actually work on bringing that pH down. But here in Northeast Iowa, we're going to be able to apply some ag lime to correct that pH. So pH works on a scale from 0 to 14. 0 being super acidic, 14 being super basic or alkaline. 7 is neutrality. That's the middle. Now, when you think about how acidic things are, it is an algorithmic scale, which means that if you were to go from a 6 to a 7, that 6 is actually 100 times more acidic than the 7 is. When we think about where we want our soils to be at for corn and soybean production, usually that 6.5 to 6.8 is a pretty sweet spot because that allows most of our nutrients to be as available as possible. Now, some crops are going to be a little bit different. You think about a crop like blueberries. Blueberries like it a lot more acidic. We look at something like alfalfa. Alfalfa wants to be closer to that 6.8, 6.9, even 7. It likes it a lot more basic. Let's take a look in the soil to see what's actually happening when we apply lime. So here's what's going on in your soil when you apply lime. So just to set the stage here a little bit, when you get your soil test report back and you see soil pH, that is the pH reading of your active acidity. So the hydrogen, because hydrogen is what makes acidity basically, the hydrogen in the soil solution is what you're testing. You're also going to see on there something called buffer pH. And what buffer pH is telling you is it's basically telling you your reserve acidity or how much hydrogen is stuck onto the soil surface. Because as we start adding lime and as we start neutralizing this active acidity, the soil chemistry likes things to be in balance. So as we start to neutralize this, the soil is going to continue to release some of this hydrogen on the soil surface as we start to tie this up. So there's two basic different kinds of ag lime that we're going to be sourcing here in Northeast Iowa. You're either going to be using calcitic lime, which is CaCO3 or calcium carbonate, or you could also be using dolomitic lime, which is magnesium carbonate, MgCO3. So as we put that into soil, this is going to start breaking down into calcium and carbonate or magnesium and carbonate. It's going to react with this hydrogen here, and it's going to form carbonic acid. You're also going to have a byproduct of a hydroxyl ion, and then you're also going to have some of these free-floating calcium and magnesium as they get knocked off of these lime particles. Now, I know it seems a little bit backwards that by trying to neutralize a hydrogen, we're making carbonic acid. But what we're really trying to do is to neutralize the active acidity and have it over here doing something else. We're also adding hydroxyl, which is the opposite of hydrogen. It does an opposite thing in the soil. And then we're also going to get these two free calcium and or magnesium. So these two, while they don't really neutralize the hydrogen, they are basic cations, which is going to help with the neutrality of that soil. Now, when it comes to should I or am I using calcitic lime or dolomitic lime, that's really just a function of where you are. For example, here in Dubuque County, the grand majority of our lime is going to be dolomitic because that's just the lime that we mine and get out of the quarries here. Now, we could go further south and truck in some calcitic lime if we wanted to, but that's just going to make that unfeasible as far as economic return because the trucking cost to get this up here is what's really going to make this expensive. Why do we have to continually apply lime? It's not like it's a fertilizer that the crop is pulling it up and then we're removing that fertilizer with our crop. So what's the deal? Well, the thing is that we continually acidify our soils. So when we think about the fact that, acidity is coming from hydrogen, particularly when we apply nitrogen fertilizers. Great example is anhydrous ammonia. Ammonia is NH3. So we are putting hydrogen into the soil when we apply anhydrous ammonia. Urea, we are incorporated and applying more hydrogen. Urea is also a portion of UAN, or urea ammonium nitrate, our solution fertilizers. We are also removing some of that calcium and magnesium. And again, while the calcium and magnesium in our limes aren't actually neutralizing the hydrogen, they are basic cations that are being taken out of the soil. That's the Cliff Notes on soil pH in Northeast Iowa. If you have any questions, call, text, or email.